All right, let's talk about, so in the intestine, I break it down into, I talk about small intestine, liver, and pancreas kind of all together, because intestinal activities are impossible without pancreatic and hepatic activities. And then very briefly, large intestine, there's not much about it. And then we talk about absorption in small intestine as well. So we're going to start with specifically duodenum. So why I focus on duodenum? Most absorptive activities occur in the duodenum. They do happen into other parts, in the jejunum and in the ileum. As a matter of fact, here's the thing. Let me explain what I mean by we don't have to go into that level of details on the exam, but digestion to a pretty much the biggest extent happens in the duodenum. Absorption happens in the jejunum and even more in the ileum. For instance, people with Crohn's disease, Crohn's colitis, they have inflamed and dysfunctional ileum, which significantly impairs their ability to absorb food, which results in weight loss and cramps and diarrhea, specifically ileum. It's called ileitis. But the digestion per se, more in the duodenum. So you have, as usual, you have two types of activities, right? You have mechanical digestion and chemical digestion. We're going to focus on chemical mostly, because mechanical digestion in the entire intestine, it's all about segmentation. So intestine basically, so you have a bunch of chyme, bolus, and two adjacent parts will contract, and then they will dilate, and then another part will contract. So basically like moving chyme back and forth around, okay? So it mixes with the juices, digestive juices there. So another activity that happens in the small intestine is absorption. And for absorption, you need a lot of surface area. Make sense? So know three structures that increase surface area. Those are circular folds. So circular folds are, well, what they are, like a thread on inside of the I'm stepping in the wrong territory. Engineering is not my strong part. But like a thread on a screw, you know what I'm talking about? Circular folds. They just move food in circles so it retains longer in the intestine. Then you have villi. They actually can be seen with the naked eye if you look at the intestine. They're very tiny, about millimeter tall. They make, so clean intestine looks velvety because of the villi. And then microvilli, which are an interesting beast. So if you have a cell, a columnar cell, right? The membrane folds on the surface of the cell are microvilli. They membrane folds, right? And these microvilli form like this whole thing here. It's called brush border. Does that make sense? So the structure of the intestinal wall is the classic four-layered, mucosa, submucosa, muscularis externa, and serosa. So I'm not going to stop on that. We talked about it before. Cell types. So we've got absorptive cells. It's got given absorption. We've got goblet cells, which produce mucus. Enteroendocrine cells. And Paneth cells. Paneth P should be capitalized because it's a dude. Okay, so let's touch on the functions again. So absorptive cell absorption, goblet cells, production of mucus. Enteroendocrine cells, exactly what you think it is, hormones. And Paneth cells serve as resident phagocytes, so they kill microbes, so to say. Good? So now I want to, the mucus here that's produced in the intestine is kind of neutral-ish with a little bit of basic hint. So pH in the small intestine is around 8. It's not too basic, but it's not completely neutral. Does that make sense? So now I have a chance to talk about one of my favorite regulatory mechanisms, which is the regulation of the intestinal activities by two hormones, which is going to be cholecystokinin and secretin. So as usual, the stimulus will be food, right? But not just food. So duodenum, where does it get chyme, that digested food, from? The stomach. So it's pretty much well digested. So what is the pH of that chyme? Acidic, yeah. I'm not asking any complicated questions. So acidic. And also, there's some fats, you know. Okay, from the stomach, right? Ends up in the duodenum. So, intestine per se, the cells in the intestine, like absorptive cell and, goblet cells, all they produce is mucus. We're going to touch upon the digestive enzymes that can be found in the intestine, but so far, just mucus, right? So where do digestive enzymes and all digestive aid come from? So they come from pancreas and they come from liver. So when acidic and fatty chyme enter small intestine, they stimulate the production of two hormones. One of them is secretin. So secretin has a dual effect on two organs. Secretin, first and foremost, acts on the pancreas. Now, look at the logic here, physiological logic. Secretin is stimulated, I deliberately drew the line from acidic, right? So it is stimulated by acid. So it stimulates pancreas to produce, what do you think? Negative feedback. Huh?
Bicarbonate.
Base, yes, bicarbonate. Excellent, bicarbonate. Okay? And then it also acts, the wrong arrow. Secretin also acts on the liver. Okay? And the only secretion in the liver that I know of that has basic pH is bile. Now, disclaimer, listen. Secretin is not particularly good on bile generation. I mean, it does stimulate a little bit, but not a lot. Maybe I'm going to put a little. Okay? Does that make sense? Now, what about fat? So fat triggers the release of hormone called cholecystokinin. I'm going to use acronym because it's a mouthful and a handful to write. But if you think about the name cholecysto, cholate, so basically gall. Cysto, cyst, empty pocket, bladder. Kinin, moving. CCK makes your gallbladder contract. That makes sense? So, gallbladder will then release the bile. And I specifically mentioned, look, it's a release. Gallbladder doesn't produce anything. It releases the bile. Now, bile, we will talk about the role of bile in digestion of fats in a second, okay? But here's another question. You not only need bile to digest fats, you also need enzymes. And CCK will stimulate pancreas to release digestive enzymes. Does that make sense? Excellent. So let's talk about it. Let's go over this one more time. When acidic and fatty chyme enters the intestine, acid stimulates the release of secretin. Secretin in turn massively stimulates the release of bicarbonate from pancreas, which neutralizes the acid, and stimulates the release of bile, generation of bile by liver, but just a tiny little bit. CCK, released in response to fats, results in the gallbladder contractions that release bile, essential for fat digestion. And also CCK stimulates pancreas that produces, in response to that stimulation, digestive enzymes. Does that make sense to you?
Yeah.
Good. Excellent. Okay. Questions about that part so far? Okay.